Okay, what next? There is a point also important, although you said it's like alah, senang je, lectures had got 3, flip-flop got 4, but this is the thing that you need to remember. Normally in part A question theory, it will ask a simple things, because part A normally your marks will be only 1 until 2. So a very simple question for multiple choice only might be slightly confusing. Maybe we put get GR at the flip-flop, so you can see is it correct or not. So something like that. You need to remember what is the specific latch for under latches. You can see there is a SR latch, and I mentioned yesterday SR latch is not gate SR latch. Although you can see here the name is nearly equal or same, but there is gate in front. It mentions that you have EN input. This EN input is the priority rather than your second input, which is SNR. And another one is your get delash. Your get delash is like much more easier, as mentioned yesterday, because you have only one input, so the possibilities for you to remember for the output only two. D either 0 or D either 1. And the output yesterday, it will follow exactly the input, isn't it? So the Q will be 0 if your D is 0, and if D is 1, your Q will be 1. And again, you need to remember the SR latch and the get SR latch. It is totally similar in terms of the table, the summarized table. But the only different when you have the EN. So let me draw the table so you can remember. And it got active high and active low. So for active high SR, whether it is a get or SR latch, you have EN if you have get SR. But for SR, normally you're going to have if EN is 0, nothing change, no change for your output. What is the meaning by no change? It's going to follow your previous Q. That's why your sequential logic circuit got the memory to remember the previous output. So that's why it's not change. And if let's say for EN it got as a 1 there, it is enables, turn on the latch. So you have 0, 0, 0, 1, 1, 0, 1, 1. This thing no need for me to explain, because this is the possibilities that you might have for S and R. And if 0, 0, you're going to have NC, which is no change. 0, 1, you're going to have reset. Remember what is reset? Reset is going to trigger to 0 for the Q. And then 1, 0 is going to be set or refer to 1. And 1, 1 is going to be invalid. It will be a vice versa for your active flow. For active flow, if your EN, SR, Q, will be similar if EN is equal to 0, because everything will be turned off. So doesn't matter, it's no change. But then for 1, 1, 1 is going to be vice versa from your active high. 0, 0 invalid. 0, 1 set or equal to 1. 1, 0 reset or 0. And lastly, no change for 1, 1. So only these tables you need to remember, so it's slightly easier for you. If you remember, then you can answer. But to answer, you need to know how to apply this summarized table into your timing diagram. And this is SR. And just now I already mentioned about the D, which is if D, EN, Q, 0, nothing happen, no change. If it's 1, it will be 0 and 1. And similar to your Q, 0 and 1 also. Okay. Now, this is the thing that we discussed yesterday. S for set, R for reset, D for data. And in terms of the combination circuit, I ask you to look into, you can try to put and play around with the input value and the previous Q output to generate what is the next Q. So you can play around with the value, and yesterday also I already derived. That's why I can come out with this active high table. This one we already take a look into, and yesterday we already looked into the several equation. What else? Okay. All these things I hope that you already try. I want to accept your friend to just join us. Okay. So today we're going to directly go to our flip-flop, because yesterday we already gone through for our lectures. Now for flip-flop, you have 3: SR, H trigger, D, JK, and T. And a frequent use, normally we use JK flip-flop. In the daily activities, this is the frequent flip-flop that will be used. Okay, you can see flip-flop. Yesterday, I informed already what is the biggest differentiation. Although you can see here, you got SR. Okay. This is your SR for lectures. And if let's say you have the get SR latch, you have the EN there, something like this. But if you have flip-flop, whatever flip-flop, SR, H trigger, JK, and T, this part will be changed to be this symbol. This one is what? This is CLK, clock. For this icon, it will be active high. If you got bubble here, it is active low. Similar to our lectures yesterday. Only in terms of this is clock. You can see what else? So FS H trigger is going to look into the clock. If let's say, okay, it's rising up, it's going to be positive. Falling down, it's going to be negative. This is the example. When you have a waveform, so there is a part that you can see from 0 to 1, from 0 to 1, from 0 to 1, from 0 to 1. We call this as positive going pulse, rising up, which is rising or leading edge, from low to high, from low to high, from low to high. When this case happen, it will be look like this, which is positive clock. And positive clock, normally in terms of your timing diagram in the equation, sometimes it will be given like this. The hint directly given positive clock, but sometimes it's just draw in your block diagram. But normally, in terms of your waveform, there will be an arrow pointing up like this. It will be not doing like this. Okay, wait. It's not going to pointing up like this side, because your signal or your wave will be moving from left to right. If you pointing up like this, it look like it moving from right to left. That's why this is invalid. You cannot draw like this. Okay, that is on rising up or positive going pulse or a positive clock. So if let's say you have here, I need to carefully delete this. And if you have negative clock, what will happen when you have negative clock? The symbol will be like this. In the question, sometimes it will give you directly the hint that it is negative clock. But in the waveform also, because you were given with the timing diagram, there will be an arrow pointing down, which is a move from 1 to 0, 1 to 0, from high to low, high to low, high to low. And it is not going to draw at this side, because when you draw at this side, it look like it moved to the left. Instead, you need to pointing to down there, it moves to your normal movement of waveform from left to the right. Okay, so that is about your clock. You need to understand about this clock, because your waveform will be triggered only at this specific line. Now I'm going to show you the difference. Yesterday, I dah buat recap a bit, right? I already shows you some recap that we're going to have a difference of the waveform, although our input here, you can see S and R, and also N, also a clock, is totally similar, but our latch output and our flip-flop output is different. So let's take a look one by one first. We're going to look at EN because it's going to be a latch. Okay, here. First thing, yesterday, I suruh you buat apa? What I asked you to do? Draw the dotted line for every changes at your input. This is your input, this is your input, including your EN. Because if you still remember, this is your latch. You have S, R, Q bar. This side is output, this side is your input, which is S, EN, and R. So you need to draw your dotted line at your input one by one. So let's redraw the dotted line. I tukar warna lah. Maybe black. So here, I'm going to consider for set. So there is a changes here. So I'm going to draw like this. And then another change here. Another change. No change for the set, already done. For a reset now, reset 0, 0, 0, 0, 0. Oh, suddenly there is a changes at this side. from 0 to 1. Okay, done. From 1 is changed here to 0. And then I have from 0 to 1. And another one is from 1 to 0. I'm done with my reset. And then another input is my EN. So here is the changes at my EN side at the dotted line that already set here. And another one is this one. Here there is a changes. Here there is a changes. Here got the changes, and lastly at this part, this is also a change. Okay, done. Second, what I need to do, fill in all the value. Here 0, here is 1, here is 1. Every single at the dotted in between, I'm going to fill the value. 0, 0, 0, 0, 0, 0, 0, 0. Here is 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0. And then for EN here, 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 0. And for the latch, 0, 0, 1. Kenapa I buat latch? Okay, now it's finished already. First of all, for our latch, we're going to look into the EN. So for our EN, if it is, okay, I draw the table, EN. For our SR latch, there is a Q. If it is 0, nothing happen, no change. If it is 1, it's going to be 0, 0, no change. What else? 0, 1, reset. I put the number only. 1, 0, set. And 1, 1, invalid. Okay, from this, I'm going to look into my EN first. EN is 0, no change. EN is 0, no change. I stop at every single dotted I already created. I have 1 there. At 1, I need to consider my SR. So what is the value for my SR? My SR is 1, 0. So I'm going to go to 1 here. 1, I stop at the dotted line. My EN now is 0. What is happening? No change until I meet another dotted line. I stop and look into on the input. I can see the changes at my EN. My EN now is 1. And I look into my input for this side. It is 0 and 0. 0 and 0, no change. So I continue. So please make sure you can see, although it is very small changes in between there, it is lucky for this question, it will be 0, 0. But if let's say your value like this, okay, I give you let's say like this, and then here will be like this. It will be 0, here will be 1. What will happen? Your output will be changed. You can see here at this small part, your input is 0, 1. 0, 1 is 0. So you're going to go to 0. Another one here. There is another one. You need to consider this part for the input. Now it is, let's say this one is up. So 1, 0, 1, 0 is 1. So your output will be like this. So please make sure, draw the very carefully dotted line to check every single changes for your input. So now in this scenario, you have for 1 you can divide into 2 right here. For these changes, you have 0 and 0, which is no change. You continue until the next dotted line, and you check at your input, EN is 1. And at this particular dotted line, it is 0, 1. 0, 1 means 0. So that's why you're going to go to 0. Stop at the next dotted line. You can see your EN is 0, which is no change. Stop here, you check your EN, it is 0, no change. Stop here and check your EN, it is 0, it is no change. Now your EN is 1, so you need to look up to your input S and R. So S and R at this part is 0, 1. 0, 1 is 0, so you remain 0. Stop here, you can see your EN is 0, it is 0. Your EN is 0, no change. So this is your answer for your latch. So how about your flip-flop? What makes is different? Okay, wait, I need to carefully delete. Okay, for flip-flop, you're not going to look EN whether it is 1 or 0. And also there is no EN. You're going to have a clock. Although a clock, you have the similar value 1010, but the most important at the clock is at the arrow there. If arrow is pointing up, it's going to be a positive clock. Positive clock, positive clock. It doesn't matter whether it is a positive clock, was pointing up, pointing down, pointing up, pointing down, pointing up, pointing down, pointing up, pointing down. So it doesn't matter as long as you know, okay, for this problem, for this flip-flop, it is active high. So active high, you look into the pointing up only for positive clock. So you just need to see the changes at this specific line, not all this area. Okay, just now for your ledgers, you look all this area if it is at 1. But for flip-flop, you just look at the specific line, at this specific line, at this specific line. The rest in between, you're not going to consider or you just ignore. Okay, we go for our output. Now I'm going to change my color. Here, first thing, let's say I have the initial value is 0. I need to directly ignore everything until I meet my clock, positive clock. Jalan until I stop because I meet my positive clock. My positive clock here at this side, at this line, what is the value for my input? Now my value is 1 and 0. 1 and 0, similar table, you're going to have 1. That's why you will make your output to be 1. After that, you just do nothing, follow your previous output until you meet another active high. Now you meet another active high line there. At this point, you need to stop and look into your input. What is your input at this point? It is 0 and 0. That's why you need to look. That's why you need to look into the 0 part, 0, 0. It is no change. So you continue without and then ignoring the rest until you meet another active high clock. here is your another active high clock, and at this specific line it is 0 and 1. 0 and 1 is what? 0. So you're going to change and just continue until you meet another active clock. So you can see there is a difference between latch and flip-flop, although it is similar input for set, reset, EN, and clock. Okay, any question?
So far, okay.
No question, doctor. For now, clear.
Okay. Let's we proceed with another example. Now we go directly. This one is all the detail, similar things on their output. Just now we look into the example. And this is for SR flip-flop on the logic diagram. So you can see here, as I mentioned, you just have this symbol changes only. Last time it is EN for your latch, and now it is a clock. So let's take a look. The table also similar. You can see here it is doesn't matter whether it is positive or negative clock, totally similar table, but you just need to trigger your output changes at this specific point. If your flip-flop is positive, all must be positive. If negative, all changes must be made at the negative clock. So no need for me to explain. This one is basically similar. You can see similar to your SR latch. And directly we go to this example. We have SR clock. What I ask you to do first, I ask you to do dotted line at every single changes on your input. So here I do for my S first. And then if you already understand that which part you need to do the dotted line, you can go for like directly to the positive clock. But I suggest you to do it slowly, step by step, so you can have all the dotted line there. And then my input value, and my clock, you can put the value also, but actually clock will just depend on the arrow. Okay, done for that part. So for flip-flop, I'm going to look into the clock. This one is a positive clock. And let's say the beginning is low, and you can see there will be no changes because there is nothing trigger for your clock until you meet the positive one. Positive clock, isn't it? So this is the meet for positive clock. What happened? So you need to look at the value at this line. S is 0, R is 0. It is no change. So you just follow the previous one, which is no change, until you meet this next positive clock. At this part, my input is 1 and 0. 1 and 0, you're going to have a set or a 1. So that's why you're going to go for a 1 and continue until you meet another next positive clock. At this side, my positive clock value is 0 and 1. 0 and 1 is going to reset, means 0. So I'm going to go down and continue until I meet another next positive clock. At this line, my value is 1, 0, and my output will be set or a 1. So I'm going to continue until I meet another positive clock. At this positive clock, my value is 1, 0. So it's going to be set and 1. So this is my output. It can be asked in terms of part A question. They will be provide you with they're going to provide you with the picture. You need to select which one output is correct, or maybe for part B you need to draw by yourself. Okay, let's redo this part. So you already know that you're going to only change when you have the trigger at your clock. That's why all the dotted line is there. You can proceed to every changes. It can, but here I just follow the dotted here. I don't want to draw the dotted line for each changes at SNR, okay? It gives you the hint. Flip-flop is reset. So I'm going to put reset first. And positive edge. Of course, you already look into this is positive. And from here, I'm going to continue whatever output I have from previous until I meet positive clock. At this positive clock, what happened? The value is 0, 0. 0, 0 means no change. No change. I'm going to continue until I meet another positive clock. At this part, it is 0, 1. 0, 1 will be reset. So it's going to be similar, which is 0. Will be 0 until I meet another positive clock. Here is 1, 0. 1, 0 will be set. Set will be 1. So I will be continue until I meet another positive clock. For another positive clock, it will be 0, 1, which means by reset. It will be 0 until I meet another clock. So it will be 1, 0, which means as a set. So I'm going to go up until I meet another positive. Will be 1, 0 also. It will be set. So the Q bar, it is just a toggle from your Q. So it is not too hard. Okay, here is your output. I think it's slightly easier for your latch, because latch you need to basically see at every changes for your SNR. But now you just look into the clock at this specific line. If you still remember yesterday, I already mentioned that for me personally, flip-flop is much more easier. Only later on you have a lot of steps to do, especially when you are play around with the pre and clear. Okay, we have this one is similar things, which is you convert from your diagram to your table. And we move to our D flip-flop. Just now is our SR flip-flop. Similar, you can see D, but your EN now is the clock. This is the table, similar table you can see with your latch, only EN now change to the clock. If you have positive clock, everything must be positive clock. If you have negative clock, it must be negative clock. So let's say we have example here. At this positive clock, you're going to change. First, initially, Q is 0. And then you meet the positive clock there. What you need to do, you need to refer to your input value at this line. It is 1. So you're going to draw 1 and continue until you meet the next clock, positive clock. So at this line, you have the D. You need to refer to your input. D is 0. So you're going to follow because 0 will be 0. Follow until you meet another next positive clock. For this part, for your this line, your D is 1. If D is 1, your Q will be 1, similar with your latch. So you're going to go for a 1 and continue until your next positive clock. Now for this line, your D equal to 0. If 0 is going to be 0 also. So this is your final wave for your flip-flop. Okay, any question before we can go for a new JK, because it's slightly different. Last time we have SR and D for latch. We can basically have a knowledge, but this is a new thing. For the JK, if you have any question or maybe if I am too fast, you can stop me. For the JK, you can see here you have the input J and K. Last time it is S and R. And there is a big differentiation between SR and JK. What is the biggest differentiation and the only difference? It's going to be JK, no invalid state. So last time if you have, I cari ruang kosong ni. If you have for SR, I draw here. For SR flip-flop, of course, you have the clock. Let's say we assume it's either clock up, clock down. Your SR, your Q, 00011011, no change, reset, set, and invalid. But the only difference for JK is at this part. For JK, under your table, not for the flip-flop. JK for the table, the only things that there is no invalid. But now for JK, for 1 is going to be toggle. That is only different for the output side under JK. So here is the table. You can see 00, no change, similar to your SR. 01 is reset, similar to LR. 10 set, similar to SR, of course, active high. And then 11 for your SR, active high is going to be invalid, but for JK, it's going to be toggle. You need to remember that if you want to derive, you can go for this circuit. You key in the value in just what I did last time, then you can get the summarized table. Okay, let me see. In this example, it is changes at the positive. Yes. So here is my positive, 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 positive. So at the positive clock, I'm going to trigger a change. Starting at 0, starting at 0 initial, I'm going to continuous until I meet my next positive clock. For this side, my value is 0, 1. 0, 1, it is reset or a 0. And continue until my next positive clock. My positive clock now I have at this side is 1, 1. What is 1, 1? 1, 1 will be toggle. If my previous output is 0, I'm going to change it to be 1. If my previous output is 1, I'm going to toggle it to be 0. So here from 0, I'm going to go for a 1. And I continue until my next positive clock. I stop here because this is my positive clock. And I check the value of the input. J is 1, my K is 0. J is 1, my K is 0. One zero. So for 1 0, you can see here, this will be a set. So it's going to be continue as 1 until I meet my another next positive clock. Now the value will be 1 1. 1 1 again, it is toggle. My previous one is 1. So I'm going toggle to 0. I continue until my next positive clock. Here my next positive clock, the value is 0 0. 0 0, no change. I continue until my next positive clock. 0 0 again, it is no change. Here is 0 0, which is no change. Here is 0 0, no change, and 0 0, no change. So this is my output for my for my JK flip flop. Okay, now you can see this is another example. If you check here, it is a positive clock. Positive clock, and initially it's mentioned it's going to be low. So let's see, low, and then at this part, first you draw the dotted line already. Second, you're going to fill in the value at the dotted line. 0 0 1 1 0 1 1 0 1 0 1 1 0 1. Okay. Now I'm going to draw my output Q. 0 0. It will be no change. I'm going to continue. 1 1 is going to be toggle. 0 1 is going to be reset. 1 0 is going to be set. 1 0 is going to be set. 1 1 is going to be toggle. 1 0 0 1 is going to be reset. Reset, toggle, set, reset, toggle, no change. So this is your output. Okay, now we can see here. Yes, it is similar. You have no change at this part. There is a toggle, reset, set, toggle, reset. Okay, we have now slightly different only at the clock. The clock is now negative. So I'm going to only refer to the negative clock. I draw the dotted line at the negative clock, and I'm going to name my value for the J and K at the specific line 1010. Correct. My initial value is low. So this is my low until I meet another negative clock. At this side, it is 11. 11 will be toggle until I meet another negative clock. 00, no change. So I'm going to continue until I meet another next negative clock. 01, it will be reset. And I meet another negative clock, it will be set 10. Until I meet another negative clock, I see this is set. So continue. So this is my output. Either it is, as I mentioned, either it is a positive clock or negative clock, the output will be similar. It is slightly similar to your SR, but the only difference at this side, which is there is no invalid. Instead, it's going to change to toggle. Any question? Any question for your JK flip-flop?
So far, okay.
Okay, so we're going to continue. With our T flip-flop. For our T flip-flop, it also called as a toggle flip-flop. It is slightly similar to your D last time, but D will follow. If you see D, if D equal to 0, your output will be 0. If your input is 1, it's going to be 1 also for your Q. But when you see the toggle, of course, it's going to be toggle in terms of the value. But which part that will be toggle? Of course, toggle is going to be either one only. So it will be only toggle when you have T equal to 1. If T is 0, it's going to be no change. So the CLK, the table summarization that you can make is whether it is a positive or negative clock, whether it is positive or negative clock for T equal to 1 or equal to 0. For 0, you're going to be no change or whole, similar. And for 1, it's going to be toggle. So that is the things that you need to remember for your T flip-flop. Now for this example here, you have negative clock. Negative clock, you draw at the negative side, and normally in the equation it will given you the error, but you need to look into the dotted line there. It's already drawn for me, but the value I need to fill in. I have here 0, 1, 0, 1. Let me start with negative low first until we meet negative clock. At 0 here, it means no change. I continue until I meet negative clock. Another negative clock, I meet 1. 1 means toggle. So I'm going to toggle. From 0, I'm going to toggle to 1. And I continue until my next negative clock, which is 0, no change. I continue until my next negative clock, it is toggle, will be toggle. That will be my output. Okay, that is the only things about the basic under your flip-flop. Now we will look into synchronize and unsynchronize. That is the thing yesterday I mentioned. It's slightly different, but it's going to be very important. Normally in equation, of course, for part B, you're going to ask with the more advanced question rather than for the basic. Normally it's going to be asked in your part A. For your, in this picture, you have basically, can be your SR flip-flop, it can be your D flip-flop, it can be your T flip-flop, but the only difference now, you have another feed of input, which is pre and clear. In this question, it gives the JK flip-flop. Why? Because I mentioned normally the common use of flip-flop is JK flip-flop. And what happened is you need to consider the pre and clear first. Just now, when you have a normal clock, normal flip-flop without this pre and clear, you need to consider the clock first, isn't it? Then if the clock trigger, you look into the J and K. But when you have pre and clear, you need to check this pre first. This is the first thing that you need to check. If you already check, then you're going to, okay, for pre and clear, you can see this is the table. You have pre and clear. You have 0, 0, 0, 1, 1, 0, 1, 1. This table I didn't like because it is not following the sequence. If 0, 0, it is invalid. You cannot have 0, 0 for both. Okay. Then you have 0, 1. 0, 1, you're going to have a set. What meaning by set? Set is means your output of your flip-flop will be equal to 1. Or it called as unsynchronized because it just unsync using your pre and clear without looking whatever input for your J, K and clock. And then you have now 1, 0. 1, 0, you still going to do unsynchronized, which means you just look into the pre and clear. You can see unsynchronized input effect to flip-flop independent of the clock. But synchronized, you're going to look into the trigger of your flip-flop. But now you need to finish this table first. 1, 0, it will be reset, or a 0 for your flip-flop output. And lastly, 1, 1. When you have pre is 1 and clear is 1, maybe it's connected like this. You need now to do the synchronize. What is synchronize? You need to check the normal flip-flop function. Just now you already learned, right? The normal, the basic flip-flop function. You go back to the JK flip-flop. JK flip-flop, what you need to look? First, you're going to look at the clock, whether it is a positive or negative clock. If positive clock, you need to look into all the positive clock, you refer to the JK value. When you meet a positive clock, you refer to JK value. That is what happened when you have 1, 1 for your pre and clear. So first thing, you need to consider pre and clear. Second, your clock, of course, when you have 1, 1. When you have 1, 1 for pre and clear, you're going to consider your clock first. After your clock at every positive or negative, you're going to look into your input value. So you can see this table basically is similar to what I explained just now. When you have 0, 0 is going to be invalid for your output. For 0, 1, 0, 1, you're going to do set. Set for your output Q. Set will be 1. 1, 0, it will be reset and synchronize for 1, 1. If you have the JK flip-flop, either it is a positive or negative, you need to look into the clock first. After you have trigger on your clock, you're going to refer your JK flip-flop. This is your JK flip-flop table. Okay, the first example here, we have pre and clear value given at the diagram, at the waveform. And then our J and K is already given to be 1. I is 1. Draw back your JK flip-flop is 0, 0, 0, 1, 1, 0, 1, 1. At 1, 1, what happened is going to be toggle. So you just need to remember this. I think so. And this is positive clock. Whatever happened at the positive, you're going to trigger later on if only your pre is 1 and your clear is 1. The rest, you need to consider the output as synchronized. So let's check every changes at your input. Pre is changed here. Pre is changed here. And no change. And clear is changed at this side only. Okay, done. I'm going to fill in the value. Here will be 1. This one is 1. Of course, this is the initial point, nothing happened. And then here will be 0. And this is 1. And at this part, I have 1 and 1. 1 and 1, 1 and 1, 1 and 1, 1 and 1. Here 1, 0, 1, 0, 1, 0. Okay, for 1, 1, for initial 1, 1, you can see what you need to look. You're going to look into your JK because it's synchronized. First, you need to look for JK is your clock. But there is no positive clock or anything here. You just proceed until your next changes for your pre and clear. Now our pre is 0, our clear is 1. Pre, clear, output 0, 0, 0, 1, 1, 0, 1, 1, set, reset, invalid, and this one is flip-flop or synchronize. Okay, for this part is 0, 1. It will be set. I'm going to set until I made a changes I meet a changes at my pre and clear. Now there is a change for my pre and clear. I can see now it is 1, 1. If 1, 1, it will be synchronized. I need to refer to the JK flip-flop table. But my JK value, I already know it's high always. So this is the only thing that I need to refer. And I'm going to trigger my flip-flop at the positive clock. Now you can see at this side there is no mid o'clock anymore until I meet at this clock. You can see here. At this clock now I have 1 1 again for pre, and it going to toggle until I meet. There is no changes at all at my pre. Okay, my pre is 1 1, my pre is 1 1, which is I need to refer to the JK flip-flop. My next clocks, I'm going to do toggle again. My next clock, I'm going to do a toggle again. My next clock, I'm going to do a toggle again. My next clock, I'm going to do a toggle again. So until here only, because after that, I can see the changes value at my pre and clear. When I have a changes, which is 1 0, I refer back here. 1 0 is reset. So without concern about my clock, without concern about my JK, I'm going to reset until finish. So that is the thing. It's slightly step by step. You can see this is the thing I mentioned yesterday. Although it's easier for you to look only at a specific point, but when you have the pre and clear, you need to have step by step. And you are lucky at this question because it gives you directly hi. You need to refer only the toggle part. But when you were given with this one is what, okay, with the example, this one is similar things, similar, okay, with the example, this is the solution with the example that you have different kind of input J and K, which is following the waveform, so you need to check very clear in terms of the output. So all this part is basically the things explaining what I explained in this example. And now we have another example. We have find the output of Q and initially it high. So I put high first. And first thing I need to consider about my clear and my pre. So every changes at my pre and clear, I will do the dotted line first. Okay, this is the dotted line for my pre and clear. Okay, done. Then for this side, it is better for you to do all, okay, as I mentioned. But if I draw too many here, it's going to be mess. For C and clear, the table pre-clear is going to be 0, 0, 0, 1, 1, 0, 1, 1. Invalid, set, reset, and synchronize. Synchronize means look at your flip-flop. Your flip-flop is going to be look at first your clock. Now our clock, it doesn't give the hint whether it is positive or not. But if I look at this dotted line, I can see it is a negative. So let's say we assume the question will be given. It is a negative clock, negative clock, negative clock, negative clock. JK 00011011. No change. Reset. Set. Toggle. Okay, we done with the references that we need for our question here. Now, what happened? Okay, for now, I have all this clock. First thing first, I'm going to look into my pre and clear. My pre and clear, now you can put all the value inside, but when I'm put here, everything will be mess because this space is too small for me. It will be 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, now I have 1, 1 as a synchronize at this part. But for starting, I have 0, 1. 0, 1 is set. So you can see 0, 1 is set. So it's follow set here. Set is a 1. I have 1, 1 all over here. What is mean by this? You need to refer to the clock. To the clock here, then you need to put all the value inside at the negative until this one only. Here will be 0, 1, 1, 1, 1, 0, and 1, 0. What is the output for 0, 1? Here I'm going to continue until I meet the negative clock. 0, 1 will be reset. I'm going to reset until I meet another negative clock. It is 1, 1. 1, 1 will be toggle. Toggle until I meet another next negative clock. 1, 0, it will be set. And I meet another one, 1, 0, it will be set. I finish until this 1, 1 only. And I have changes at my clear and pre. Now my pre is 0, my clear is 1. 0, 1, it will be set. So I continue with I continue for set there. This one is just now set. This will be reset. This will be toggle. This will be set, set, and now I have a set also. Here there is a changes again. It will be 1, 1. 1, 1, 1, 1, 1, 1, 1, 1. From this point to here, it will be 1, 1, 1, 1. That's why I need to consider my flip-flop. Flip-flop, I'm going to look into the clock, isn't it? At the negative clock here. Here will be continue until the next, until negative clock. And then I stop first. I need to check the value. This is 1, 0. This is 1, 1. This is 0, 1 and 0, 1. For 1, 0, it's going to be set. So I continue until my next negative clock. It is 1, 1. It will be toggle. Toggle continue until my next negative clock. It will be 0, 1. 0, 1 will be reset. Continue until this only. So for this part, I have a change for my clear and pre. My pre is 1 and my clear is 0. 1, 0 is reset. If reset, I'm going to continue until this part. because I can see there is another changes. Now it's 1-1 until the rest. 1-1, I need to consider back my flip-flop. My flip-flop is going to look into the clock. So here I continue until my next negative clock. I want to check the value. It is 0-1, 0-0, 0-0, 0-0, 1-0. Kalau I salah put the value for me, so here will be 0-1. 0-1 is reset. So it's going to be 0 also. 0-0 no change, 0-0 no change, and 1-0 is set. So that will be my answer. So you can see it's correctly from the answer given. So please try to do it slowly, step by step, with the big your paper should be big, because if you have like this small space here, it's hard for you to draw it and it will be mess like what I did just now. So if your paper is bigger and then you have plenty of, you can put space, big space between each other, so it's much more clear. Please try to do it and get the specific answer. Play around with the, maybe you change, this is K, this is J, what is the output? Ask your friend to do similar thing. Compare the answer, is it similar or not? You change here also. Maybe here is pre, here is clear. Just by changing this, totally your answer also will be changed. And maybe you change also at the clock. Now you use the positive clock. Of course, your answer also will be different. Okay? That is the only thing for you on your module 7. Finish already with our module 7. So any question? Any question for your flip-flop and also your latch?
So far, okay, Doctor.
So far good.
Okay, if there is no question, I want you to do all the exercise in the module. In next class, we're going to proceed with our module 8. Okay, so here I'm going to share one more time for your attendance. For those who already scanned, you can dismiss, and for those who still not yet scanned, please do so. Thank you and stay safe. Bye-bye.
Okay, bye. Thank you,
Thank
Doctor.
you, Doctor. Bye bye. Thank you, Doctor.
Terima kasih, Doktor.
Thank you, Doctor.
Thank you,
Thank
Doctor.
you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Okay,
Thank you,
okay,
Doctor.
bye-bye.
Thank you, Doctor.
Okay, thank you.